This is the second level structure for a 3-edge node using the vertical pipe implementation. As I mentioned in an earlier video, when I tried to make a banded pipe version of this structure of a 3-edge node interaction, I didn't find the banded pipe version, but now I've done that. It's also true, though, that if you remember that this structure is slightly curved, and although that may be an interesting property, it certainly, in a certain sense, is the property of this 6 circumference vertical pipe type of construction. I think what I'll do is I'll go and play with the 8 and 12 edge versions of this structure and see if there's still the curvature in the structure. I don't know whether there will be or not, or even if the 8 and 12 edge nodes of the vertical construction are possible. So I just noticed something funny in this structure that I hadn't noticed before. I built it a month or two ago. It turns out that these two arms are different than this arm. And that's where the curvature is, and you can see that nicely here, like this, okay? So it turns out there's one 8-edge node here, and then there are 4 7-edge nodes, like this. So the 8-edge node has a curvature of +2, and the 7s have a curvature of +1. So the total curvature of this junction is only +6, which is half of a toroidal hole. So if this were a pipe, and it effectively only had 3 curvatures, well, even that's hard to understand. So somehow the number of curvatures in this pipe are different from the curvatures in these pipes. And that's rather interesting. I then built the vertical pipe constructions for an 8 vertical pipe and a 12 vertical pipe. There's no symmetry in this 8 vertical pipe that would allow me to get 3-ness like this. I can get 4-ness like that, but I can't get 3-ness. And the same thing is true for the 12 circumference vertical pipe. I just can't get triangular behavior out of this construct. I can get perpendicular behavior like this, and we've seen that before in the cubic lattice, but not triangular behavior. So the search then for the vertical pipe construction leaves us with just this construction here, which we've seen now several times, but that the larger constructions, so far I don't have any way of finding the symmetries to this. And of course this thing is twisted. That's the point of this. So it's really rather confusing at this point. But the banded pipes have worked out. That's the thing. This is the 8 circumference banded pipe version of the second level structure of the 3-edge node. The structure is perfectly syntactic, and you can see though that it's not too weak, and it's more or less uniform, but not quite. I mean, the reason for the lack of uniformity is that there are 2 7-edge nodes here that keep the curvature very tight. And in the 12 edge circumference banded pipe that's shown next, the 7s are displaced by a node, and that makes them less curved in this particular spot. So The lack of circularity, in a certain sense, of this structure is due to the fact that the two 7-edge nodes here are adjacent to each other. It's also true that I tried to place a 6 circumference toroidal hole in this structure here, and there's just not enough structure to be able to do that, and it just wasn't possible. So these are interesting subsidiary notions about the structure of the 3-edge node, which is actually more complex than I had thought at first. This is once again the second level structure for the 3-edge node. This is, as the other was, a 12 circumference banded pipe in each of the 3 directions. What I've done here now is to insert a toroidal hole that's an up-down hole, so-called, because it consists of 12 7-edge nodes. There's an up, down, up, down, up, down, up. So this is a particular construction for a toroidal hole. One of the things that I noticed was that this entrance here is the beginning of a vertical pipe. I never realized that before. But the way the structure is constructed, there's only each of the interface nodes are directly bonded to each other. So the vertical pipe doesn't really get a chance to get started. I mean, it's started, but it's not elongated is the way to think of it. What's unfortunate about this structure is, as you can see, is that the 12 circumference pipe is very distorted. Because this hole here is so short, that has the effect of compressing the circumference of the 12 circumference banded pipe in all 3 directions. So the symmetry is there and the structure is there. It's all perfectly syntactic as far as the triangular neighborhood network syntax is concerned. But it's the same problem. It's stressed. I have this notion that you've seen perhaps several times before, that when a structure is stressed, there's something wrong with it. So what I'll do is I'll look to put in a 3 circumference pipe in the center here rather than this 6 circumference pipe, and maybe the solution will be happier. The comment in the previous section that the toroidal hole that I put there was the entrance to a vertical pipe can be demonstrated in this construction. So I've removed the toroidal hole that had been here, popped this structure out so that it's external to the 3-edge structure, and now I've extended it a bit in orange with the light blue showing that it's in fact a vertical pipe. So this is really rather interesting, that if you have a larger triangular face here, that can act as the entrance for, this is in fact a 6 circumference vertical pipe, that triangular interface can act as the place where you can attach a vertical pipe of circumference 6. This is the 12 circumference banded pipe for the second level structure of the 3-edge node. This is the construction where instead of having a 6 large triangle acting as the interface with a 6 circumference vertical pipe in it, here I have a 3 circumference banded pipe as the, remember I used the term Chevy Chase circle for such toroidal holes. But, and so you see the structure is reasonably happy. This part is of course okay, and the circumference here is largely circular, so there's a little bit of contraction in the center, but it seems to alleviate itself rather nicely. And that's because I think because there's a node between each of the 7-edge nodes. So this node here is between, it's the 6, between this 7 and this 7. And so that's the basic constraint on the structure. The toroidal here, of course, has a curvature of plus 12. There are 6 eighths here, 3 on the top and 3 on the bottom. So this toroidal hole would have its own EDS, and then the structure here would be part of a larger system. The EDS, if this were a pipe here, for example, then this pipe would have an EDS someplace in it, and same with this and same with this. This 12 circumference banded pipe has 6 7-edge nodes that connect the 3 pipes to each other. So the total curvature of the pipe system is plus 6, which, as we saw in the vertical pipe cases, is only half of a torus worth. And so that's really rather confusing at this point. You'll have to think about why this is the case, that instead of the pipe having a curvature at this end of plus 6, it only has a curvature of plus 2.